All right, the graph shows the amount of medicine M in milligrams remaining in a patient's body 8 hours after receiving an injection. The amount of the medicine decreases exponentially. Find the decay factor per 1.5 hours. So I'm first going to write the equation. So my initial value is 300 times, to figure out my decay factor, I'm going to divide 153.6 by 300. So I have to divide 153.6 by 300. And I'm just going to use my phone calculator for that. So 153.6 divided by 300 is 0.512. So it's 300 times 0.512 to the power of x, where in this case, x is the number of 1.5 hour time periods. Okay, so my decay factor per 1.5 hours is going to be equal to 0.512. So my decay factor per 1.5 hours is 0.512. Okay. For B, find the decay factor per half hour. So if I'm going from half hours to 1.5 hours, well, how many half hours are there in an hour and a half? There are 3. So I'm going to have to divide the number of half hours by 3 to convert it to 1.5 hours. So my equation per half hour is going to look like this. It's going to be 300 times 0.512 to the power of h over 3, where now h is the number of half hours. Okay? Why? Because if I plug in, let's see, 3 half hours, 3 divided by 3 is 1. That would mean 1.5 hour time periods, and that works. 6 half hours, 6 divided by 3 would be 2 1.5 hour time periods, so on and so forth. So this works. So my equation per half hour is this. Now to figure out the decay factor per half hour, I have to do that thing where I take h over 3 and I break it down into 1/3 times h. Okay? 1/3 times h is equal to h over 3. So my decay factor per half hour is this right here. It's 0.512 to the power of 1/3. So my decay factor per hour and a half is 0.512, and my decay factor per half hour is 0.512 to the power of 1/3.